Today, I'm excited to speak to you about principles of collaborative automation. I have 4 principles this morning and also 4 precautions or ironies of automation. These come out of the resilience engineering community and studies of collaboration between humans and also between humans and software. Because we don't only collaborate with people anymore. We very much collaborate with machines, computers, and programs. We do this at many scales. So on one hand, you've got like the place where the people just exist to help the software run. So in a Patriot missile, for instance, this is not a thing that could exist if humans had to make the decisions of where to go. The software on the missile is deciding that. And then somewhere back in a control center, there's a human that's somehow supposed to check on it and be there in case somebody needs to be blamed. And in machines, or in factories, you've got like big automations and nuclear power plants, and the humans there are there to help the machines in case anything goes wrong and to problem solve. In the middle then, you've got the business applications where, we write a lot of these, where people have to work with the software in order to do their job. The people can't do their work without the software, and the software can't do their work without the people. And similarly, there's software that I would have a hard time living without, such as Google Maps and navigation. I can still read a map, I'm pretty sure, but my little sister, I don't think she can, because these programs have become essential to our world. And then there's the little ones, the little games, the little Southwest app and things like that, yes, they're convenient, but we could do our work without them in another way. Similarly, as developers, we have all of these. So if I'm a developer whose job is to operate useful software, which is what I consider success, then, I'm here because of the software. And so I'm in charge of that, but it has the purpose. And then there's all these tools that I can't do this job without, such as the source control, my IDE, the deployment system, the infrastructure I run on. These are essential pieces of software. And then there's the little ones, like grep. I don't know how I would do with my job without grep, but I'm pretty sure I could figure something out if I had to. And these are little ones that we can add more of those all the time. And the difference here between everyone else and the development team is that we can change this software. The software that we operate, we also change. So if it's hard to operate, that's on us. This is kind of the point of DevOps. Similarly, we can update our deployment system. At the very least, we can add automated tests and checks and linting to our build scripts. We can customize our IDE. We do a lot to our local environment because we both work in the computer and we work on the computer. So it's different for us because we actually can change the software that we work with. And so us and the software form one socio-technical system. The code is on our team. And this is a special kind of system. It's a learning system made of learning parts. There's a word for that called semathecy. Learning system made of learning parts. We learn from each other, and we learn from our software when it throws exceptions, and our software learns from us because we change it, but we don't learn anything without our tools, without our observability and our log traces and PagerDuty. So we need all of our tools to get the learning from the software to us across and that changes the flows of mutual learning. This is a system based on flows of mutual learning between us and our software and among us. And the tricky bit is this line of representation in between, and this is why our tools, including grep, are so important because they let us see into the digital world to learn from our software and to change it. So we're unique in this. We and our software are engaged in the socio-technical system in joint activity. Now, joint activity means that we're working toward a common goal and our tasks are interrelated. So if we want to have dinner together, and I'm like, okay, you bring the meatloaf and you bake some bread, you bring a pie, and I'll do the mashed potatoes, and we'll meet back here at 6 p.m. That's not joint activity, that's just coordination. Unless we're sharing a kitchen. If we have one oven and one counter space, and maybe we want to make just one common trip to the grocery store, suddenly our tasks are intertwined and we're engaged in joint activity. Software development is all about joint activity. Our tasks are incredibly interdependent. There are 4 things that we need for joint activity to work, and I'll go through each of them. The first one is the basic compact. This is an agreement, usually unspoken, that we're all going to work toward a common purpose until further notice. The until further notice part is important, because if we quit our team, we don't just ghost, we resign. If we're not going to be in today, we call in sick. There's a finer resolution to this too, because I might say in stand-up, okay, my kids were up all night puking, and if I yell at you today, I'm sorry, it's not you, it's me. There's like a degree of collaboration that we're not quite ready for that day. And we can be specific like that. As a counterexample from another industry, okay, one time there's this airplane, and there's a fuel leak. And it would have killed them if they hadn't noticed. But they got lucky, and somebody happened to notice that the fuel gauge on the left was going down when the engines were drawing from the right. And they're like, well, that's weird. So they take a casual stroll down the aisle, and they glance out the window, and oh, yep, there goes the fuel. Keep a straight face. And only then do they go back in the cockpit and notice that the autopilot is doing this, because it's gradually compensating for the increasing weight imbalance. And it's not telling anyone that it's working that hard. Okay, collaboration is not about try harder. Collaboration is about, yo, this is harder than I thought I was. Could I get some help over here? Before the plane crashes. In our software, in our production software, this is things like health endpoints aren't yes or no. A health endpoint says, okay, I've been up since this time. I'm serving requests at this rate, and I've got this many database connections open, and my downstreams are responding at this rate, except for this one, which I think is down, so I'm using this backup stuff. Detail. And then we can work with that. We can help the software. So we have to make the health endpoint so it can help us help it. There's more to the basic compact. It also includes that when the other pillars of joint activity start to break down, we work to restore them. Liz talked about this a little bit. When we lose communication, we actively restore it. This means don't swallow errors. If you have a weakness, you want to surface it to your team, a weakness or something that's harder than you expected. Now, yeah, okay, don't show the errors to the end user usually, but do show them to the humans on your team, because that's what humans are good at, is everything you haven't programmed into the computer yet. There's another concept here of the difference between rely on and work with. I don't rely on my coworkers. I don't rely on my coworkers, my team members, to be around 24/7, to answer questions at all time, even to be in a good mood at all the time. Instead, we work together so that somebody's on vacation, somebody's sleeping, this is fine, but as a team, someone is available to answer the pager 24/7. Someone is available to answer questions in Slack during business hours. Collectively, we can be reliable, but individually as a human, that's not a thing. So we work with each other to present a more consistent front to the rest of the world. This applies to our software too. So if any software you operate, you don't rely on, you work with it. If you have queuing as part of your system and you operate Kafka, you can't rely on Kafka. 2 or 3 months, it's working fine, everything's great. All of a sudden, oh my gosh! And you're Googling, how do I restore these lost messages? Because you have no idea. You have to work with Kafka while you operate it. As opposed to, if you get Kafka as a service, then worst case scenario, you talk to a person. Because resilience isn't a thing without humans in the system. And those humans are regularly restoring messages that were lost, and they actually remember how to do it. They don't even, maybe they don't even have to Google the syntax for it. So rely on versus work with. Work with your team members and your software. You don't depend on any specific instance of your software to be up all the time, but collectively it can be 99%. All right, so that's the basic compact. The next thing is mutual predictability. We need to be able to roughly predict what the other people and software on our team are going to do in a particular situation. This gives us confidence and trust. So in stand-up, if I'm like, okay, I'm working on this ticket, and I think I'm going to add a join table to hook these two things together, and somebody else is like, what have you thought about what that's gonna do to the number of records? And so when we notice that there's a loss of predictability, we work to restore it as part of the basic compact. Counterexample from the real world, Apple likes to send messages from me, stuff like, kinda gave me a drawing, kinda is sick today. No, Apple, I have a daughter and her name is Linda. Also, in like automated car driving, right? They've got the cars that are doing this driver assist thing, and one of the things that they'll do is like if you get too close to the car in front of you, it'll hit the brakes. That might be useful, but not if you were trying to pass that car. So the trick is you're accelerating to pass that car and you use your turn signal. Your turn signal can tell the automation your intention, and that can help it predict what you're about to do and not slam on the brakes. That's important. A trivial example from real software. The other day, I installed Git on Windows, and it pops up one of those old-style installers that's like, okay, we're going to install this. I'm going to ask you where you want it, and I'm going to ask you some more questions, and then I'm going to install it, and then I'm going to tell you what I did. And it's boring, yeah, but it's predictable. It's kind of comforting that way. It builds trust. More mutual predictability in our automations, especially the automations that we write for ourselves. We need to be able to understand their state, actions, and what is about to happen. This means I don't want any AI. I don't want any machine learning, and I don't want any natural language processing in my automations that I use for myself. I mean, maybe in production software, okay, that's different because there you're justified in working hard enough on it to get past the uncanny valley of, it did what? But not locally. For instance, we used to have, we still have an automation at Atomus that if I put in a commit message that doesn't meet coding standards, it yells at me. If I'm on a branch, I might fix it. But the thing is, the capital letter stuff works fine. Does it start with a capital letter? Yes. But it thinks that I'm not using present tense if there's a single past tense verb anywhere in the commit message. That is not a good use of NLP, and we've turned that off because we're not going to work hard enough to get it right. It wouldn't be worth it, so get it out. Right. I also want my automations to be accountable, not for outcomes, that's just silly, but accountable to tell the story of why they did what they did, because that can restore predictability. Accountability is about telling the story of why something happened, about being understandable. This one time, I worked at a payment processor, and there were a lot of transactions marked as fraud from like the Netherlands or something. And it was like, well, that's weird. And then, thank you, European Union, for passing laws that require this. They added functionality in the machine learning system that would make it say which rules fired, what percentage, so you could see why it rejected them. And it was like, oh, the country code is between 35 and 37. You know, okay, 35 is like Nigeria, and 37 is like Liberia. And then right in the middle, there's the Netherlands. Once you see that, you're like, no machine learning feature. That is an enum, not an amount. Quit it with the ranges. You need your software to be explicable, to talk to you about what happened. And even better, can you make it teach you what's going on? That's the pinnacle of observability that Liz talked about this morning. So in Atomus, if I come in as a new person and I make a commit and I push it somewhere, then our delivery automation pops in and it puts up this message and it's like, okay, I'm going to do some auto fixes, I'm going to analyze the push, I'm going to fingerprint it, I'm going to version it, I'm going to do a build, blah, blah, blah. And then each of these turn green in the message as they complete. You can click through to see the log. I'm working on adding a link to the log that will let you go straight to the code that made that decision, because we as developers can change our own automations and make them teach us what they're doing, and that is awesome. Okay, next, mutual directability, because once you can predict each other, you can also change what each other's going to do. So I can say, have you thought about how many records are going to be in that join table? And I can be, oh, I didn't think it would be unreasonable. Let's discuss this further. In the computer, this means what you don't want is to walk into an office and like apply for a driver's license or something, and the person's like, computer says no. Computer, especially when we're developers, should not be in charge. positive example from production software, I used to work at an insurance company, and we had this big system. It was written in Java like around 2000, and it had no business still being in production because it had a caching layer that just plain didn't work. It did not work. And the 70 users, and we had to restart it every night. It was insurance, so they didn't care. And it was like, oh my gosh, it wouldn't have been sustainable, except it had the most beautiful admin screens ever. And as a developer and first line support, because that was the same thing, the quoters would call in and be like, oh, I got another exception, and I'd go and I'd open up and it'd show me what was in the cache and who else had a cache record for that, and I could change it or clear it out and be like, oh, try again. And so that kept that system limping along for years because I could really see and manipulate what was going on. It was directable. In my software, I want my automations to present and explain choices, not to make them for me. A lovely example of this is navigation. It used to be that you'd have navigation in your car, and it would tell you where to go, and it didn't give you choices. It was just like, please do a U-turn. Please do a U-turn. But these days, it's much better. So if I go to Google Maps, and I'm like, yo, I need to get to the airport, it's like, okay, here's my recommended route, but you might think you could take Highway 40, but that's 5 minutes slower because there's this traffic right here. You can see your alternatives, and you can see why it's making these choices. Beautiful. I also love autocompletion in Gmail lately because you type something, it's like, oh, I think you might want to say this, press tab to accept, or just keep going, and I'll get out of your way. Unlike autocorrect, which ducking goes back and changes what I already typed. I hate that. Yeah, there's another weird thing. Here's a strange property of negotiations. The party with less flexibility has more power. So if I'm a software vendor and you're a manager of a development team and you want to buy my Alphabet Soup tool, and I want to sell it to you for $30,000 a year, but you're only authorized to spend $20,000 a year, then either I come down to your price, or you're going to have to go back to your superiors and the finance people and get authorization for this, and maybe we'll have another meeting next week. Meanwhile, I'm the one with the responsibility to meet this quarter's numbers. You have the power because you have less flexibility than I do. And the same happens with computers. Now, people are maximally flexible. That's why we make great receptacles for blame. There's always something we physically could have done differently, but why would we have done that? But the computers are not. They're never going to be fully flexible. And so we need to make sure that our automations, they're never going to cover every case. They just need to get out of the way. As Liz said earlier, you can't automate anything you don't already know how to do, so just let me do it. A good example of this is dry run options in things like Make, and a lot of programs have this, where it's like you pass the dry run flag and it just tells you what it's going to do, and then you decide whether to do that, or maybe you'll just do a couple of those steps yourself. That's a good way to keep the human in charge. Okay, last one is the hardest. Common ground. Common ground is defined mathematically as the things that we both know, and we both know them, and we both know that we both know that we both know them, and we both know that we both, so on infinitely. Now, mathematically, this is impossible to achieve in the presence of uncertain message passing. Fortunately, we're humans, and there's such a thing as good enough. So if we're all in a meeting and we discuss coding standards and we decide to change one of them, then everyone in the meeting assumes that everyone in the meeting knows this stuff and it's considered common ground. And the basic compact says when we notice that it's breaking down, we restore it. So as we're pairing and I start violating that code standard that we just agreed on, you're like, Jess, didn't we say we were gonna? And I'm like, oh, did we? Thank you for informing me of that, because I must have been asleep. The other thing about maintaining common ground is we want to share information with each other on the team, but not all the information. That's the same as no information. No, you don't need my dashboard that helped me in the last incident. I stream on Twitch sometimes when I'm working because I'm working on open source and I can. And does the rest of the company watch? No, they could, but they've got their own things to do. Part of conserving or preserving common ground is respecting each other's attention and giving people the right information. Counterexample from healthcare is when the nurse logs into a patient record and they get 6 pop-ups. Okay, just let me do my job. Well, some of those pop-ups are crucially important, like this medication and this medication could have this really bad effect given together, and you should talk to the doctor about that. But if that's right next to, oh my gosh, we're almost out of bed sheets, then the nurse isn't going to see that. Respect each other's attention. This is very important in your pages, in your log messages, stuff like that. One thing that I love lately as I'm working toward common ground is I'm trying to learn front-end development. Hint, it's so much harder than back-end. But one thing that really helps is between me and my software, a breakdown in common ground is present whenever there's a bug. I thought it works one way. It actually works this other way. Oh, we better talk about that. And I really appreciate the many levels at which I can restore common ground with the software. So in the browser, I can look at the page, but I can look at the HTML and the elements. I can look at the React tab in Chrome debugger. I can see the styles. I can see the JavaScript that my TypeScript compiled to, which is very readable JavaScript. JavaScript, it's the bytecode of the web. It's so much more readable than JVM bytecode. I like it. I can see the JSON going back and forth. All of this stuff that's human readable is valuable because it lets us restore common ground with our software at many levels. So I appreciate that. More on common ground. The thing is that our limitation as developers is not what we can do, it's how much we can know, because we cannot have the whole system in our head at once. It's too complex, and that's okay, and that's good, because we need complexity in our software. That's why it exists. Yes, some of it is unnecessary, but some of it is our entire reason for existing. John Allspaw talks about how success begets complexity, which begets success. Because the purpose of our software is to take a bunch of knowledge out of the heads of the people who are using it. So I don't have to know how to read a map. More specifically, I don't have to read a map while I'm driving. And that is valuable. Also, for resilience, you need complexity. You have to add layers. You have to add complications to build that reliability on top of individually unreliable parts. But the more success you have, the more customers you have to support, and the more backwards compatibility you need, and the more complexity you get, but then you support all those things so you can have more success. Complexity is essential. Don't try to stomp it all out. Some of it, yes, but most of it, no. The trick is to balance it with increased feedback. And that's where our observability comes in. Care about the operator interface. Okay, the operator is you. Your experience matters. One easy trick for this. Error messages are a great time to restore common ground. When you thought it worked one way and it didn't, and it tells you with a help and guidance message. See, just rename it. Naming is powerful. And suddenly, you have something useful and a way to restore common ground with the person who's trying to use whatever it is. I love those. Okay, common ground is really hard, but it's incredibly valuable. So work at it. All right, those are the 4 pillars of joint activity. We need to surface weaknesses within our team, display and explain our plans, especially in our automations, keep the human in charge. Right. So do tell me what you're doing, but be careful with my attention. Now it's time for the gratuitous cat picture. This is Pixie and Odin helping me prepare this talk. They are remarkably talented at being in the way. And now it's time for the 4 ironies of automation. These are things that people think automation will make easier, and it actually makes them harder. First, you think that the smarter your automation, the cleverer your AI, the less intelligence you need in your human operators. And the opposite is true. Okay, automation does not save you money. It adds capability. It means that you can get those approvals to your customers in 2 seconds instead of 4 to 6 weeks. But behind the scenes, you've got people operating that software who understand all the intricacies of the approvals. You actually have to know more to operate smarter software. You need to be trained in problem solving, not in procedures. Computer can do the procedures. People need to solve the everything else. That's what we're good at. So no, your people get more expensive, sorry. The next one is you want to care about the happy path, because that happens 90% of the time. But it's 1 in 1,000 possible cases. So the exceptions are the rule. Start from the exceptional case and make it just not the end of the world. Worst case, fall back to a human. That's what we're good at. And especially in automations that we write for ourselves, well, we could have done it. I mean, we knew how to do it already. So just make sure the error doesn't delete anything permanently. And then let the human compensate. And then we can gradually increase the cases that we have automated. Third, watch out. The more of the easy stuff you automate, the harder it is when you get to the hard stuff, because your brain isn't in the game. You're off thinking about other things, which is great. But then when you do have to deal with Kafka failing, and so far it hasn't failed yet, it's going to be really hard. And that's why specialization can help a lot, because it lets people be in that mode of dealing with the hard stuff regularly. So be careful with that. Finally, we've talked about this one already. The less flexible party has more power. Your automation's never going to be fully flexible, so keep the human in charge. Make the best path obvious and easy, but never mandatory. As developers, we are uniquely able to overcome all of these ironies of automation in the way that people who can only use automation and can't change it can't do. We can overcome these because we're all part of the same system. And we can choose to put things below the line where we want speed, power, and consistency. Yes, I want like code style consistency. Don't make me do it. Just put that in a robot, please. And then when stuff requires social skills, when it's new, when we need to solve new problems all the time, that's what people are good at. We're the ones who know why we're doing this at all. And that's important. So as developers, we get to choose which side of the line each task can fall on, and we get to work on these flows of mutual learning. Because the thing is, we need to keep learning because it's never going to be perfect. Your coworkers are never going to be perfect. Your automations are never going to be perfect. So make them collaborative. A lot of thinking went into this talk, very little of it mine. Here are some references. The end.